Great. So I'm here to teach you about circle slash and how great it is for in and out games. This is a game that I created, so it is not one from LSAT, but I did test it out. It's perfectly fine. It works. I have this kind of saved so you can practice it on your own, but I'll go through the questions in the scenario and kind of teach you how to do circle slash so then you can also rewatch this video if you have any questions. So basically, to start off with circle slash, we have a circle, we have a circle and we have slash. The circle means that our variable is in, the slash means that our variable is out. Pretty self-explanatory. You do not have to use circle, you do not have to use slash. It's just kind of like a common sense thing. You can use triangles if you want, you can use squares if you want. I use circle, I use slash, so that's what I'm going to be using when I teach you this. And so that's just kind of designating what the circle and what the slash means in respect to this game. So the scenario says a park director has to select from among 7 bands to play at the upcoming festival. We have G, H, I, J, K, L, and M, and the following constraints apply. At this point in any logic game, I would usually kind of set up some type of board, whether it be an ordering game or a grouping game. I kind of get my basics down and get an idea of where I'm going to be placing my variables, what my board's going to look like. But in circle slash, this is my board. My variables are my board. So I don't have to do anything else beyond what I already have written down. Before we go into the actual rules, our variables are not assigned right now. We don't know if M is in or out because it's neither circled nor slashed. We don't know what it's going to be assigned to at this point. That could change when we go into our rules, but at this point, we don't know what's going on. And so all of our variables right now are considered to be floaters. At this point in the game, they could either be in or they could be out, and it's not going to violate what we've already gone over right now. So let's go into rule number 1, which says if M is chosen, then G must also be chosen. Okay, so ask yourself, in this world, in world number 1, do we know where M is? We don't because it's not circled or slashed. So we're going to make a copy. Label this number 2. We're make a copy. And because we only have 2 options, it being in and it being out, we're going to make that happen. So we're going to circle one and we're going to slash the other. It does not matter which one you circle. It does not matter which one you slash, so long as you have one circled and one slashed. That's all we need. And so now, because I know where M is placed, I can go back to my rule and I can go, okay, if M is chosen. That only applies in world number 1 because we know that M is circled. Well, what must happen? Then G must also be chosen. So that means that G has to be circled when M is circled. Going on to my diagram number 2, we can't apply this rule. We know where M is out, but the rule only applies when M is chosen. And so because M is out in this world and we don't have any rule, well, we do have a rule later on, but this rule does not apply when M is not chosen. If M is not chosen, we can't do anything. We don't know what happens at this point in the game if M is not chosen. So we're going to leave it as is because G could either be in or it could be out. So we've fully implemented this rule. We don't have to worry about that rule anymore because we've assigned where our M's go and we've applied that rule. Moving on to rule number 2, if G is chosen, then L must also be chosen. Every time we go into a new rule, we have to go all the way back up to our first diagram. And that's because when we're making these diagrams, we're making all the different scenarios that are happening. And so all of our scenarios have to abide by all of our rules. So every time I go into a new rule, I have to make sure that my world number 1, my world number 2, my world number 3, they have to apply to all of these rules. So going back up to world number 1, if G is chosen, then L must also be chosen. Ask yourself, do you know where G is? In world number 1, we do. We know that it's in. So what happens? Can that rule apply? Well, it can because it's when G is in. So that means that L must also be in. So I'm going to circle L. Going to our next world, do we know where G is? We don't because it's neither circled nor slashed. So we're going to make an exact copy of this world so we can make that happen. Notice how I'm not circling or slashing G in that second world right now. I'm making my exact copy. Before you circle or slash any variable, if you do not know where it's at, you've got to make a copy before you circle or slash it. Once you've made a copy, you can then circle one and slash the other. Doesn't matter which one you do. The reason that we create the second world before we circle or slash in our original world is because it's so you can get an idea of, okay, what were my original variables? My original variables I knew were M, that M was out basically. But if I had decided to just circle G in world number 2 before making my world number 3, and then I apply the rule, okay, L is also circled, then when I go to make my copy, I might be like, crap, I don't remember which one was originally there because technically L was not circled in my original world. So making a copy where G is out and L is in or something like that, that's actually not necessarily true. It doesn't necessarily have to happen. So make your copy before you circle or slash any variable and then apply the rule. So we have our G circled and our G slashed. Okay, well the rule only applies when G is circled. So in world number 2, that happens. We know that G is circled. We know where G is at. So then that means that we can apply the rule, which says that L must also be chosen. So we're going to circle L. And going into our world number 3, G is not chosen. We know that it's out. And so because the rule that we're working with right now does not say what happens when G is out, we can't do anything to this world. We can't circle, we can't slash L. Technically, you could circle and slash L. You could make the copy and circle and slash L, but you could also do that to K. You could also do that to J. You could also do that to I, and so on and so on. So it's really not in the best way of like not saving time, but it's going to cause a lot of worlds to happen, and that's really not the most efficient way to do this. So we're only focusing on that sufficient condition. When the sufficient condition is not met, like in 3, then we don't do anything. That rule is dead to world number 3 because it doesn't apply. So now that we've had G chosen, we're going to cross this rule out because we don't have to worry about it anymore. It's baked into our diagram. Moving on to rule number 3, if K is not chosen, then H is chosen. Okay, new rule, we gotta go all the way back up to world number 1, right? Do we know where K is in world number 1? We don't, because it's not circled or slashed. So what do? When you don't know where a variable is and it's your sufficient condition variable, we're gonna make a new copy. And again, we're gonna copy exactly world number 1. And we're gonna circle one and we're gonna slash the other. Now we can look and see where our rule applies. Our rule applies when K is not chosen. So can we do anything in world number 1? We can't because K is circled, so therefore the rule does not apply. However, in world number 4, K is not chosen, which means that this rule does apply. So when K is not chosen, we know that H must be chosen. So move on to world number 2. Do we know where K is? We don't. So we're going to create a whole new copy. Oops, I was looking at my wrong one. Okay, number 2. I, J, K, L, and M is slashed out. Okay, so we have our whole new copy. We're going to circle one and we're going to slash the other. Again, it doesn't matter which one you circle, which one you slash. Then ask yourself where the rule applies. Well, because K is circled in number 2, it does not apply. But in world number 5, because K is not chosen, then we know what happens. We know that H must be chosen. And number 3, we do not know where K is right now, so we're going to create a whole new copy so then we do know where K is. And again, because there's only 2 options, that's why we're creating our copy, and we're circling one and we're slashing the other. So in world number 3, can the rule apply? It can't, because we know that K is not chosen, and that's when the rule applies, but in our world, K is chosen. So the rule technically is completely dead to world number 3. However, number 6, K is not chosen. Our rule says what happens when K is not chosen, and that means that H must be chosen, which results in that. So now that I've gone through all of my worlds, I can completely forget about this rule. We don't have to worry about it. It's baked into my diagrams. I don't have to think about it anymore. Moving on to my next rule, which says if M is not chosen, then I is chosen. Okay, so whole new rule. We're going to go back up to world number 1. Does this rule apply? It does not, because in world number 1, we have M chosen, and that's not what the rule is saying. The rule only applies when M is not chosen. So we can't do anything to world number 1. World number 2 and 3, we can, because we know where M is placed, and because M is out, the rule applies. When M is out, we know that then I must be chosen. So we can circle I in 2 and 3. Going to world number 4, again, same thing with world number 1. Because M is chosen and the rule only applies when M is not chosen, we can't apply this rule to the world. Nothing happens. We don't know what happens when M is chosen, because that is not, well, we know that G is also chosen, but in relation to I, we don't know what happens because that's not what the rule is stating. So we leave it as is. And then 5 and 6, same thing as 2 and 3. We know where M is placed. We know that M is out. We have them crossed out. And because we know that, we then know that I must also be chosen. And so since I've gone through all of my worlds and I've applied this rule, don't have to worry about it anymore. That rule is a very easy, and I love getting rules like that where I'm not having to make copies of worlds, but it's always not that nice to us. And so when we get a rule like that where we have our variable place and we just have to bake it into our diagram, feel lucky. That's a great thing. It's a great feeling. Okay. So our last rule says that if L is chosen, then neither J nor H is chosen. Okay, whole new rule, right? So we're gonna go all the way back up to world number 1. If L is chosen, that's when this rule applies. Do we know where L is? We do. We know that L is circled. And so what happens when L is circled? Then that means we can't have H and we can't have J. So because this is our last rule, this is a valid world. And we'll go back and kind of, I'll talk about how I and is a floater right now, but we've applied all the rules. This is what world number 1 is giving us. Moving to number 2, the rule applies when L is chosen. Do we know where L is? It is in, so it's circled. So that means that we can apply this rule, which means that we automatically know that that means that neither H nor J can be chosen. So again, because that's our last rule, I'm going to check mark it and let myself know that I don't have to worry about any other rules with this one. Moving to number 3, the rule applies when L is chosen. Do we know where L is? We don't, because it's a floater. It could go in, it can go out. So before I do anything with L in world number 3, we're going to make a copy, number 7, which is crossing out J or G, H, I, J, circle I, K, L, and M. And we're going to circle one and we're going to slash the other. In my world number 3, L is chosen, which means that the rule can apply, which means J nor H can be chosen. However, going back down to my copy world where L is not chosen, that rule cannot apply because the rule only applies when L is chosen. So I know that world number 3 and world number 7, good to go. World number 4, do we know where L is? We do. It is circled. So that means that according to our rule, J and H cannot happen. But we have H circled. At this point, I don't really remember where that came from. I think it's from our rule number 3, but that's the beauty of baking in your rules. You don't really care, it's happening. So because L is chosen and because the rule says that J and H then cannot be chosen, this violates our last rule, which means that it dies. It cannot happen because every world that we've created has to abide by all of our rules. It can't just pick and choose. So because it violates that last rule, it can't happen. So we don't care about that world anymore. Moving on to world number 5, we have L is chosen. So the rule does apply. We do know where L is. And so that means that neither J nor H can happen. Oops, H is circled. Don't really care how it got circled, but that means that this world dies because it's violating that last rule. So we can cross this one out. Okay, last world. World number 6, do we know where L is? We don't because it's not circled or slashed. So we're going to create another world. And we're going to circle one and we're going to slash the other. So in world number 6, when L is circled, that means that our last rule applies, which means neither J nor H can happen. But in number 6, we have H circled, which means this world dies again. So we don't care about it. Going to our last world, L is not circled. So because the rule only applies when L is chosen, we can't do anything to this world. So the rule does not apply, and we'll just check mark it and know that that is good. So going through all of our rules, we've gone through all of them. We've come up with 5 different worlds. In world number 1, we know that G, K, L, and M have to be in. H and J have to be out. However, I is a floater, which means it can be in or it could be out, and it's not going to violate our rules. So I could have I in, I could have I out, and that world stands. And number 2 and number 3, all of our variables are placed. We don't really have any questions about where a variable might go. Doesn't matter. And then in number 7, H and J are floaters. So we know that it can either be in, it could be out, they could both be in, they could both be out. Either way, because we've gone through all of our rules, we can have either situation happen and that world is still valid. And again, that happens in number 8 as well, where we have J as a floater. So it could be in, it could be out. It's not going to violate our rules. So that world can stand. Okay. And that's pretty much circle slash. I don't really have any questions to this game. I mean, I don't have any questions to this game. So this is just kind of how to set up circle slash, how to implement it into your diagram, not necessarily how to go about questions or anything like that. But if you would like to go over maybe like a real LSAT problem with a circle slash method or an in and out game like that, feel free to message me and we can set up a time to do so. But this is going to be kind of a video just to introduce you to circle slash, see how it applies, and hopefully get you a little comfortable. And if you are doing actual LSAT games, you can kind of refer to this video to kind of remind yourself, okay, what are the questions I'm asking? When do I make that copy of the world? What happens when the variable does not conform with the sufficient condition in the rule, kind of like a reference manual. So that's pretty much all that I have. Again, if you have any questions, feel free to reach out to me, and I will talk to you later. Bye.